And good morning, everybody. Here are your notes and examples for IXL.com, Algebra 1, Module AA.6, and it's going to be on factoring quadratics still, but it's going to be covering two special cases, so kind of two shortcuts that will allow us to find the factors of certain situations a little bit quicker. And let's go ahead and look at the first pattern. So the first pattern is going to be if you have what they call a difference of two perfect squares. So if you had a squared minus b squared, then it's going to factor out to be a plus b and a minus b. So it's going to be the same a and b values. The only difference is in one of the binomials it's going to be plus, and in the other one it's going to be minus. The reason this works is if we went in and kind of checked this by remultiplying. So if you did a times a, you get a squared. If you do a times the negative b, you get negative ab. If you do b times the a, you get ab. And if you do b times a negative b, positive times a negative is a negative. And b times b is b squared. And if you simplify, negative ab and the same thing, positive ab, those are opposite like terms, so those are going to cancel. And what you're left with is a squared minus b squared. So this is the original or the standard form, and then this is going to be the factoring pattern. So let's just do a quick example with some numbers. So for example, let's say we had a problem, let's say it was x squared minus 4. So the first thing we want to notice is we have a difference. It does have to be a difference, it has to be subtraction in order for this to work. If there was a plus sign there, this pattern would not work. And then we need to notice that we have perfect squares on both terms. So by perfect squares, something that can be multiplied by itself to produce the value that you have. So for example, the x squared is just x times x. So that's what we call a perfect square. Because if you took the square root of x squared, you get x. And the 4 is a perfect square, because we know that 2 times 2 is going to get you 4. So these are perfect squares. So this is going to follow that a squared minus b squared factoring pattern. So a squared minus b squared will factor out to be a plus b and a minus b. And you're going to have a difference in signs, a plus and a minus. And these a and b values are basically going to be the square roots of those perfect squares. So for this original problem, it's going to factor out to two factors. We have a plus sign and a minus sign. And what's the square root of x squared? That's going to be x. And what's the square root of 4? That's going to be 2. And there's your answer. So that is a difference of two perfect squares. Let's try another one real quick. So let's say we have x squared minus 25. Then we have a difference of two perfect squares. One will be plus, one will be minus. The square root of x squared is x. And the square root of 25 is 5. And there are your two factors. And let's just try one more. So let's say we had some more numbers involved. Let's say we had a 4x squared minus a 9. So again, we have a difference. We have two perfect squares because we know 2x times 2x is 4x squared, and 3 times 3 is 9. So it's going to be a plus and a minus. So the square root of 4x squared should get you 2x, because the 2x times 2x is 4x squared. And then to make the back number, the 9, we need a 3 times a 3. And there's your two factors. And the next factoring pattern is going to be what they call a squared binomial. So let's say I have a binomial, a plus b, and it's all being squared. Then if we were to square this out, a plus b multiplied by itself, a plus b, and if we multiply this, we get a squared. We get a times b, which is positive a times b. And then we get b times a, which is positive a times b. And we get positive b times positive b, that's going to be positive b squared. And then notice the two middle terms are actually identical, so they double. So we're going to get a squared plus 2ab plus b squared. So for this next factoring pattern, we're actually going to be looking for this pattern kind of right here to show up. And we're going to be factoring it back to its original factors. So we'll write the pattern in just a second and then do a few examples. It also works for subtraction on this one. So let's say we had a minus b all squared. If you were to multiply this, then the only difference is you're going to get a subtraction on the middle term. So we have the a times a, which is the a squared. A times the negative b is negative ab. Negative b times positive a is a negative ab. And a negative times a negative, that's going to be positive b squared. So notice your two middle terms are both negative. So you're going to get a squared minus 2ab plus b squared. And again, we're going to be looking for this standard form. And if we see this pattern, then we're going to be able to factor it back to its original two factors, which is a squared binomial. So let's write the pattern down. So here are the two formulas, or the two patterns. So if you see the original standard form, and it's following this pattern where basically if you square root the a squared, you get a. And if you square root the b squared, you get b. And then if you double that, then you end up producing the middle term. So if you see that pattern where you can square root the beginning of it and the end of it, and then double that product and make the middle, then that means you have this factoring pattern. And then you can either write it either as repeat factors, so you could write it as just repeat factors, or in some cases you could simplify that a little bit further and say you have the same two factors being multiplied against each other, so you could write it as a square. So it's a plus b times a plus b. So we're looking for this pattern where we can square root the ends, multiply and double, and if we make that middle term, then we know we have that factoring pattern. And then the other one is the same pattern. The only difference is you have a plus sign. So if you see a minus sign here on that middle term, then you're going to have a minus sign in your factoring pattern. And let's go ahead and look at a few examples. So let's say this was the problem we were given and we're asked to factor it. You can still use the other techniques that we've been studying, where you do factors of the back times the front that sum up to be the middle and factor it that way. Or when the numbers get larger, like especially in the IXL.com, as you get further into the modules, like up into the SMART score of 80s and 90s, the numbers get really big and it's probably faster to use the pattern. If the numbers are relatively small, it probably doesn't make too much of a difference. So if we were to look at this, notice if I square root the 81, we get 9. And if I square root the a squared, the 1a squared, then we get a. And then notice if you double that, then you get the 18a squared. Or 18a, excuse me, not 18a squared. So if you double that, you end up with that middle term. So if you can square root the two squares on the ends and then double it to make the middle, then we know we have this factoring pattern. So to factor this, we know it's going to be a plus sign. And then we're just going to go ahead and put in the square roots of the first term and the last term. So if we look at the square root of a squared, that's going to be a. So a times a is making the a squared. And if you square root the 81, then we get 9. And those would be your two factors. So you have repeat factors. A plus 9 multiplied by itself, a plus 9. It is possible that some people might prefer the squared form. IXL, I'm not sure if they're going to accept either form, but you could write this as a squared binomial. So it's a plus 9 being squared because you're multiplying it against itself. So this would be your squared binomial. And again, if you don't pick up on the special pattern, it's not always that big of a deal. You can still factor it using our traditional factoring techniques. So if I was to factor this original problem without trying to notice the special pattern, we know it's going to come from two factors. We're going to need an a and an a to make the a squared. And we're going to be looking for factors of 81 that add up to be 18. So if you look for things that multiply to be 81 but add to be 18, we know 1 and 81, we're eventually going to come across the fact that 9 times 9 is 81, which makes the 18. So there's your 9 and your 9, and they both need to be plus to make a positive 81 when you multiply, but a positive 18a in the middle when you add them. So you're going to come to the same conclusion just using the traditional techniques that we've been studying. But again, for the IXL.com modules, when you get to the later ones, the numbers are going to be rather large. So instead of spending a lot of time looking for that correct combination, it's probably going to be faster to notice that special pattern. And let's go ahead and do one more example, then we'll do a few more example problems from IXL.com. And here's your example. So again, if you don't pick up on the special factoring pattern, you would just have to use the traditional technique of doing factors of the back times the front that sum up to be the middle and find the correct combination of numbers. But if we slow down and look for that special pattern, so notice we have a perfect square on the front, and we know the square root of 4a squared should be 2a, because 2a times 2a gets you 4a squared. And we notice this is a perfect square. The square root of 9 is 3, because 3 times 3 is 9. And if we multiply these two together, then we get the 6a. And we have to be able to multiply these perfect squares, square roots together. And then we also have to multiply it by 2, so we have to double it. And if we double that, then we get 2 times the 6, which is 12. So we get the 12a in the middle, which is what we're looking for. So this is going to be another special pattern. So we're going to have repeat binomials. It's going to be subtraction in each one because we have a negative 12a. So So we have a negative here, so we're going to have subtraction. And then we're just going to put in the square roots. So what is the square root of 4a squared? That should be a 2a times a 2a. And what is the square root of 9? That should be 3 times 3. And there's your two factors. As always, you can check it by multiplying. 2a times 2a is 4a squared. 2a times a negative 3 is negative 6a. Negative 3 times a 2a is another negative 6a. And negative 3 times negative 3 is positive 9. So if we simplify, we get 4a squared minus 12a plus 9. So that's what we had originally, so looks like it checks out. So again, these are your two factors. And you can write those as a squared binomial also. So if you wanted to write it as just having 2a minus 3 multiplied by itself or squared, that would be another way to write that. So either one of these two would represent the factors for that original problem. And let's go ahead and look at a few examples from IXL.com. So here's the first one. So if we are looking for the pattern, so this whole module, it's going to be kind of trying to identify that pattern. So if we look at the front term as being a perfect square, so what is the square root of c squared? We know c times c is c squared, so it's going to be c. What is the square root of 1? That should be 1. And if we double that, then we need to produce the middle term to have this special pattern, which 2 times 1c is 2c. So there is our middle term that we're looking for. So the two factors, it's going to be plus, since we have a plus on the middle term. And then we just put in the square roots. So what's the square root of c squared? That's c times c. And what's the square root of 1? That's 1, because 1 times 1. So there's your two factors. I'm not actually sure if IXL.com will accept this form. If it doesn't, then you just want to go the extra step and write that as a binomial squared. So we have the same factor showing up. So we can just write that as c plus 1 being squared. Just make sure it's in parentheses. And let's try another one. So notice this one does not have a middle term. It just has a front and a back. So this is the difference of two perfect squares. So this is a squared minus b squared factoring pattern. And that's going to factor out to be a plus b and a minus b. So we know it's going to follow that form. And what are the square roots? So the square root of p squared is just p times p, and the square root of 1 is 1 times 1. So there are your two factors. These you cannot write as a binomial squared because they are two different factors. One's plus in the middle and one is minus in the middle. And here's another difference of two perfect squares factoring pattern. So we know it's going to be an a plus b, a minus b factoring pattern. And we just put in the square roots. So what is the square root of 16d squared? That should be a 4d. And a 4d, because 4d times 4d is 16d squared. And then what's the square root of the 25? That should be 5 times 5. And there are your two factors. And this one looks like another squared binomial pattern, so let's just check. So what is the square root of 4f squared? That should be 2f. What's the square root of 25? That should be 5. So 5 times the 2f should get you 10f. And then you need to be able to double that to make the middle. So if we do 2 times that, you're going to get 20f. which makes the middle term. So this is going to be that special squared binomial pattern. It's going to be plus, since we have a plus sign. And then put in your square roots. So it's going to be a 2f and a 2f to make the 4f squared. And then we needed a 5 and a 5 to make the 25. And the 5 2f and the other 5 2f are making that middle 20f, because it's basically a 10f and a 10f that are making the 20f. And if you wanted to write that as a squared binomial, we have 2f plus 5 being multiplied by itself, 2f plus 5. Here's another difference of two perfect squares. So it's going to be a plus b, a minus b, and put in the square roots. M times m is the m squared. 5 times 5 makes the 25. And here's one more with the other special pattern. So again, for this module, they're all special patterns. If you were just doing regular factoring, you wouldn't know, so you'd have to kind of go through and check to see if it is a special pattern. So if we look at the square root of the 9g squared, so it's going to be 3g, because 3g times 3g is 9g squared, multiplied by the square root of the back one, which is 7. 7 times 7 is 49. 7 times 3g is 21g. And then if you double the 21g, that makes 42g, which is that middle term. So again, this is a special pattern, and it's going to be minus because we have a minus on the middle term. So both factors are going to be minus, and then you just put in the square roots. So the square root of 9g squared is 3g, and the square root of 49 is 7. So there's your two repeat factors, and you can write that as a squared binomial since you have two of the same factors being multiplied. So there's your final answer. And that's all the notes and examples for this module. This was Algebra 1, AA.6, factoring quadratics, but using special factoring patterns.